This is our e-learning lesson for May 3rd, 2021. We are going to be working in section 6.3c, converting a rectangular equation to a polar equation. As you can see from our notes, a polar equation is an equation whose variables are in r and theta. To convert a rectangular equation, which is in x and y, to a polar equation, which is in r and theta, what we want to do is replace the variable x with r cosine theta and the variable y with r sine theta. We do that because we know that is what x and y are equivalent to from our previous lesson. So you can see we have 4 examples that we are going to go through. The first one, we are given the equation x plus y equals 5. I hope you recognize that as a linear equation, especially if we solved it for y. What we're going to do, though, is replace x and y here, as I said, with r cosine theta, and then y with r sine theta. And so our equation now becomes r cosine theta plus r sine theta equals 5. Of course, we should recognize we have a common factor of r that we can factor out on the left-hand side, and that leaves us with r times the quantity cosine theta plus sine theta equals 5. And what we always want to do when we convert to polar form is we want to solve the equation for r. So at this point, to solve for r, hopefully it becomes obvious that we want to divide both sides by cosine theta plus sine theta. And so now we've taken our rectangular equation and converted it to polar form. Let's try a second equation. This time our equation, which is also linear, 3x minus y equals 6, when we replace x, we're going to have 3 times r cosine theta minus r sine theta equals 6. We'll go ahead and factor r out of both terms on the left, which leaves us with 3 cosine theta minus sine theta, in parentheses, equals 6. And now, like before, we'll divide both sides by 3 cosine theta minus sine theta. And now we are in polar form, solved for r. So the first 2 equations were pretty easy. These next ones are going to be equations in rectangular form that represent circles. I hope you recognize in number 3, it's the equation of a circle that has a center of 1, 0 and a radius of 1. I'm going to go ahead algebraically and simplify the quantity x minus 1 squared first before I substitute in for x to make it a little easier. So when I do that, I get x squared minus 2x plus 1 plus y squared, plus y squared equals 1. Now I'm going to replace every x with r cosine theta and each y with r sine theta. So we have r cosine theta quantity squared minus 2 times r cosine theta plus 1 plus the quantity r sine theta squared equals 1. That kind of goes a little off the screen. So on the left side, we get r squared cosine squared theta minus 2r cosine theta plus 1 plus r squared sine squared theta. And I'm going to go ahead and subtract 1. And when I do that, of course, the 1's are going to cancel. So that 1 and that 1 are going to undo each other. And so now I'm going to do a little creative regrouping. I am going to group together the r squared cosine squared theta and the r squared sine squared theta together, and I'm going to factor out, well, let me do that first. I've got r squared cosine squared theta plus r squared sine squared theta minus 2r cosine theta equals 0. The beautiful thing about the first two terms is if I factor out r squared from the first two terms, that's going to leave me in parentheses with cosine squared plus sine squared theta. And we should recognize that that is equivalent to 1. So now we can cross out all of this because that really is equivalent to 1. And so we really have r squared minus 2r cosine theta equals, that should be a 0 on the right side. That's my mistake. That should have been 0. So at this point, I can factor out an r from both terms, and I have r times the quantity r minus 2 cosine theta equals 0. That gives me two solutions, r equals 0 or r equals 2 cosine theta. So the thing about r equals 0 is that r equals 0 is really a single point, which is the pole. So when r equals 0, you could say theta equals pi over 2, and it's really unnecessary to have that if we have the other equation, r equals 2 cosine theta, because at pi over 2, the cosine would be 0, the x-coordinate, and 2 times 0 is 0. So my point is, I don't need to have r equals 0. The other equation would include where r would equal 0 and is sufficient to cover both equations. So our original equation, the quantity x minus 1 squared plus y squared equals 1, in polar form becomes r equals 2 cosine theta. Let's try one more. Our final problem, very similar. Again, I'm going to simplify before I substitute in the quantity y plus 1 squared. I think it's a little easier to do that. So I have y squared plus 2y plus 1. And then I'm going to replace our x with our cosine theta and our y's each with our sine theta. So I end up with what you see here. Oops, that kind of went up a little funky. So at this point, when I go to simplify, on the left side I have r squared cosine squared theta plus r squared sine squared theta plus 2r sine theta plus 1 equals 1. Of course, if I go to subtract 1 from both sides, those cancel. And we know we can factor r squared out of the first two terms. So we'd have cosine squared theta plus sine squared theta. And then we have plus 2r sine theta equals 0. So, of course, the r cosine squared plus sine squared cancels because that's equivalent to 1. And we really have r squared plus 2r sine theta equals 0. We factor out an r from both terms. And what results is we get r equals 0 or r equals negative 2 sine theta. And again, we can think about where the sine is 0. It would be 0 at 0 or pi, and therefore would include the value of r equals 0, since negative 2 times 0 is 0. So we can cross that out, and we can say the polar form of this equation is r equals negative 2 sine theta. All right, so I hope you understand that converting from a rectangular equation to a polar equation is actually quite easy. All we need to do is replace each x in the equation with r cosine theta and each y in the equation with r sine theta. And then we do want to solve the equation algebraically for r. As far as what you're doing, you will do in MyMathLab section 6.3c, and it will be due on Wednesday, May 5th, and I hope you have a great day. Thanks.